Plug Power, or simply Plug, is a company involved in the production, storage, and delivery of hydrogen for energy generation. Their distribution model can deliver hydrogen products and services directly to its customers or through joint venture partners. The uses for hydrogen technology are extensive, ranging from e-mobility and stationary power to supply chain logistics and industrial applications. So let's see how Plug fits into the hydrogen ecosystem by outlining what they offer, while also outlining obstacles in the way of wider hydrogen power adoption and challenges involving labor. When talking about Plug, fuel cells are among one of their signature products. Fuel cells are electrochemical devices that combine hydrogen and oxygen to produce electricity and heat without combustion. One of the primary uses for their GenDrive PEM fuel cell system has been to power electric industrial vehicles such as forklifts. Fuel cells enable the replacement of lead-acid batteries and can be applied to stationary and mobile use. In terms of producing hydrogen, Plug has their proton exchange membrane PEM electrolyzers that use electricity from renewable sources like solar to split water into hydrogen and oxygen, enabling customers to generate hydrogen for relatively high power density since it carries low weight and volume and operates at relatively low temperatures, resulting in PEM electrolyzers having quick start times that help lessen wear and tear on the system. The main electrolyzer designs are 5 megawatt and 10 megawatt electrolyzer systems that are modular so as to be scalable. Some of the main customers targeted for electrolyzer sales have been refineries, producers of chemicals, steel, fertilizer, and commercial refueling stations that gain the ability to generate hydrogen on site. For increased production to support more PEM electrolyzers, Plug has their so-called Gigafactory, producing electrolyzer stacks in Rochester and Slingerlands, New York, while liquid hydrogen production takes place in their Kingsland, Georgia facility, with more construction underway for several new hydrogen plants throughout the United States, including in New York, Louisiana, and Texas. The company also offers hydrogen liquefiers, which are utilized so hydrogen can be used as a refrigerant, which ties in with their cryogenic segment. Since Plug designs and manufactures liquid hydrogen cryogenic, delivery trailers, vaporizers, portable equipment, liquid storage tanks, and integrated control systems as part of GenFuel, their liquid hydrogen fueling, delivery, generation, storage, and dispensing system. Cryogenic equipment can also be used to handle liquefied oxygen, argon, nitrogen, and other cryogenic gases in addition to hydrogen. With this foundation of capabilities, Plug intends to keep expanding hydrogen production, with a stated focus on both output capabilities and geography, meaning greater quantities of hydrogen are going to be produced in more locations, leading to ongoing plans to build a hydrogen network across the United States and Europe, with plans for a hydrogen production plant at the Port of Antwerp-Bruges and 3 plants in Finland, along with joint ventures for other projects in France and Spain, and in Asia to an extent such as with SKENS in South Korea. In terms of electrolyzers, efforts are going towards scaling up comprehensive and economical solutions that are focused on the 5 megawatt and 10 megawatt variants that Plug calls the building blocks to reach into the gigawatt scale electrolyzer market. Expansion is also set to target transport applications for the on-road vehicle market that includes tractors, cargo vans, buses, and Class 6, 7, and 8 trucks, centering on products like ProGen, their fuel cell stack, and engine technology, used for both mobility and stationary fuel cell systems, and as engines in electric delivery vans. This includes Plug's membrane electrode assembly, MEA, a critical component of the fuel cell stack used in zero-emission fuel cell EV engines. Real-world application of this technology commonly takes the form of partnerships such as the delivery van and light commercial vehicle collaboration between Plug Power France, a wholly owned subsidiary of Plug Power, and Renault in France, each party having 50% ownership of the resulting joint venture called Hyvia. Plug will also keep exploring hydrogen power uses in the aviation market in the areas of commuter and cargo planes and drones. In regards to stationary power, attention is going to focus on the large-scale stationary power market for backup and continuous power applications, such as for data centers, microgrids, distribution centers, and EV charging, along with being replacements for batteries and diesel generators. This is achieved with the modular PEM fuel cell approach of GenSure, Plug's stationary fuel cell solution. In support of all these various hydrogen systems, there is GenCare, which the company calls their Internet of Things, based maintenance and on-site service program for GenDrive fuel cell systems, GenSure fuel cell systems, GenFuel hydrogen storage and dispensing products, and ProGen fuel cell engines. Overall, demand for clean hydrogen, due to the growing desire for a low-carbon energy source, has been a driving force for customers reaching out from so-called hard-to-decarbonize industries, such as heavy-duty transportation, heavy manufacturing of steel, cement, aluminum, and chemicals, stationary power generation, and aviation. Plug states their orders at any given time are comprised of fuel cells, hydrogen installations, maintenance services, electrolyzers, liquefiers, hydrogen trailers, and hydrogen fuel deliveries, with the specific elements of the orders having varied terms of timing of delivery, resulting in timelines of anywhere from 90 days to 10 years, with fuel cells and hydrogen installations being delivered near term, while maintenance services and hydrogen fuel deliveries are being delivered over a longer period of time. One concern for possible delays arises from shortages of materials needed to produce fuel cell and hydrogen generation equipment components due to factors such as constraints in the production of global semiconductors and labor shortages. And since Plug offers mobile and backup power solutions, they are up against extensive competition. This would go beyond just companies offering products such as those offering hydrogen generation via steam methane reformers. It would also include backup power options from what Plug calls well-established battery and combustion generator products, such as traditional diesel generators. While cleaner renewable energy like solar and wind can also eat into the market share to provide power. For more on solar energy, check out the video about First Solar. With respect to electric industrial vehicles such as forklifts, Plug explains they have an advantage over commonly used lithium-ion and lead-acid batteries, due to hydrogen fuel cells providing more sustained power than batteries and recharging faster, as well as not requiring significant power to be drawn from a local electrical grid. For stationary power products, in backup and intermittent power applications, Plug contends with diesel generators, which have been the go-to option for decades. Their established use poses a barrier for hydrogen power. In contrast, charging electric vehicles presents a new and emerging niche opportunity to power vehicles while not being connected to the electrical grid. Then for continuous power applications, Plug's hydrogen systems provide another option or even an alternative to distributed energy, such as natural gas turbines. On the subject of hydrogen generation and storage, Plug faces competition from companies offering similar products, mainly from what are termed legacy industrial gas companies that also produce hydrogen, as well as companies that produce PEM electrolyzers, liquefiers, and cryogenic transportation and storage equipment. Plug asserts their products are designed to be more efficient on operating costs alongside vertically integrated end-to-end hydrogen solutions, meaning adjacent and related systems such as their hydrogen liquefaction system and hydrogen tanker, which are purported to have higher capacity and efficiency. From Plug's perspective, competitive factors in the markets in which they operate include product features such as size and weight, relative price and performance, lifetime operating cost, including any maintenance and support, product quality and reliability, safety, ease of use, footprint, rapid integration with existing equipment and processes, as well as customer support design innovation, marketing and distribution capability, service and support, and corporate reputation. With that in mind, it is interesting that Plug claims neither they nor their competitors can achieve a significant proprietary position on the basic technologies currently used in PEM fuel cell systems. However, they still place importance on protecting the intellectual property of the design and integration of their systems, components, and some of the low-cost manufacturing processes. For example, those relating to fuel cell components that reduce manufacturing part count, fuel cell system designs that lend themselves to mass manufacturing, and improvements to fuel cell system efficiency. Then, although hydrogen is proposed as a cleaner alternative form of energy, it still produces waste and falls under environmental regulations, particularly those related to contamination, which can significantly increase the costs of operations if compliance is required. In general, environmental policies are getting stricter over time. They can be of greater concern if laws and regulations in the future restrict or prohibit the uses of certain materials, chemicals, and/or components that are needed for Plug's products and technologies. When considering the role of supply chain logistics, Plug states, most components essential to their business are generally available from multiple sources. However, there are macro factors that lead to some component suppliers and manufacturing vendors of materials being in limited supply worldwide, as well as the supply of some commodities that have a high degree of volatility due to political factors and economic trends. Consequently, Plug continues to mitigate these risks by diversifying their supply chain so as to source from multiple fuel cell, electrolyzer stack, and air supply component vendors, while also focusing on automation, dual sourcing of critical components, insourcing, and localized manufacturing when feasible. In relation to the service side of their business, Plug has experienced inflationary increases in labor, parts, and related overhead, ultimately contributing to the increase in their estimated projected costs to service fuel cell systems and related infrastructure. Furthermore, the increasingly competitive labor market has resulted in longer times to fill open positions within the company and for suppliers and vendors. Likewise, increased employee turnover, labor shortages, and reassessments of employee responsibilities have changed the availability of workers, leading to increased costs for components and raw materials. With all these considerations in mind, Plug and the hydrogen power industry present potential for cleaner power generation, yet still encounter persisting barriers to wide adoption. For more on related industries such as electric vehicles, please have a look at some recent uploads and stay tuned for new videos coming soon. Thanks for watching and have a nice day.